thank you so much. Thank you so much. And again, thank you for coming to my talk today. There are other talks, so for you to spend the time here, I want to thank you. And again, my talk will be about Apache Pulsar. I also did a survey, or actually 2 questions on the poll on the WOFA application, because I wanted to get a feel of how many of you are already doing event streaming and knowing about Apache Pulsar. So it doesn't seem like there are many yet, but I guarantee you after this conference, you probably will know more. Because there's also Tim Span too. I don't know if Tim is here. Tim Span, oh, he's right there. So Tim was gonna be also talking about Pulsar. He's from Stream Native, and that's for tomorrow. So we want to be promoting Apache Pulsar and bring you like the good news of using Pulsar. So with that, let me start because it's already been a bit delayed. But first of all, I wanted to thank you again to all the Spring I/O organizers, and especially Sergey Almar. Don't know if he's here or not, but he actually went out of his way because initially I thought I couldn't come, and also I'm from Chicago, so there are all the COVID travel restrictions and everything, and he ended up calling all of the embassies, Spanish embassies in the US. That's what he told me, and I ended up going to the Chicago embassy, but anyway, the long story short, I'm here now, so that's all good. So I want to thank you again to Sergey for having gone out of his way to make this happen. So thank you, thank you, thank you, thank you. So yep, and it's great to be in Barcelona, such a beautiful city, and the weather, actually all of Spain, because I've been also in Madrid too, and actually David is here too, and I was there. I just love Spain, so thank you so much for having me here. And also, today, if you are interested in my slide deck while I'm going through it, this is a bit.ly link. If you can quickly type that or get the QR code here. Otherwise, too, I'll be sharing the slide deck, too. OK, so first of all, who is Mary? I'm a senior developer advocate at DataStax, and it's a company that specializes in big data and big data, data management. Cassandra, that's the managed Cassandra platform. That's like the flagship. So no SQL, and now we're getting into streaming and also the cloud-native platform. Previously, I was with IBM for about 3.5 years as the Java developer advocate, and working with Billy too. I think Billy is here as a speaker too. So Billy Colando. So, and I'm based in Chicago. I'm also a Java champion, and also president and board member of the Chicago Java Users Group. So you're all invited to join our hybrid, or actually online meetups too, if you like, and I'll give you the link and let me know. And I actually, before becoming an advocate, I was about 20 years or so working with Java in the IT field. So I kind of understand the problems, especially if you're developers, what you're facing, facing all the difficulties, especially you're doing production support as well, which I have as well. And here are all the links as to how you can get a hold of me, but I will share that with you afterwards. Without further ado, well, this is another slide that describes me, the company slide. So DataStax, the developer, I'm really passionate advocate. I travel everywhere now. Also, too, I have my own Twitch stream as well, and other things. So. OK, so let me start because we don't have as much time. So first of all, just wanted to iron out some concepts of event streaming, event processing, event messaging, all of these. And I'm finding that it's kind of, I'm getting a mixed answers whenever I ask people, are you working with events? And they're like, coming back with like different answers. And I do feel that there's a need to iron out some of these terminologies first. And then there are also event processing, the semantics, using PubSub and using queuing. And then also like why event streaming, right? Because you can do things without events too, obviously, but wanting to kind of discuss a bit as to like why event streaming in particular. And then I'll lead you into an introduction of Apache Pulsar and its dependencies on the Apache Zookeeper and Bookkeeper. And then I wanted to also emphasize, too, Apache Pulsar is here in another open source project that's intended, or at least in my mind, it's more like extending the capability that Kafka has. I'm not here to like fight and everything, but I think there's a lot of really good points about Pulsar that we need to be advertising about. And also a bit about how to work with Spring, too. So first of all, the many facets of computing events. First of all, too, let's talk about event, right? Generically speaking, what is an event? It's funny, too, actually. remember I actually did another talk for another conference, and then the organizer was saying that, oh, you want to change the title to like event, and she was kind of confusing it with events, meaning that you go to a basketball game, going to a soccer or football game here, and I said, no, 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 it's event streaming and like that. And so it is very true, we need to kind of understand, right, and why the word of event. So essentially, too, if I look into the dictionary, right, Merriam-Webster.com, first description of it is that it's about something that just happens, it's an occurrence. So then if you kind of look through the list of all the definition, the fourth one, actually, I find it very interesting because it brings in that nerdiness now and about the theory of relativity. It's essentially the fundamental entity of observed physical reality represented by a point. Okay, that's a lot of these nerdy stuff, right? So, but essentially, too, if you're a math major, if you know math, then it's essentially the X, Y, Z coordinates, right? It is something that happens, an event. But to kind of put it into computing is interesting because then you bring in the fourth dimension, which is of time. So you bring in the time-space kind of continuum and basically postulated by the theory of relativity. So it's really, events is an occurrence that's happening in time. So to think of it, to do it in computer science is actually a big challenge. And how do you track, all of the things that are changing, the state, the changes that kind of occurs over time. But for me, too, I'm always interested in this aspect. So that's why I'm kind of, I first was, when I was in IBM, I did reactive systems. So it's sort of like related to events kind of thing, too. But it's not quite exactly the reactive definition. But still, they're very closely related. But I find it to be so exciting about doing events. It's kind of not the same as what we all have grown up with, right, in this field. We are all taught to do programming the synchronous way. When you do something, you give a request, and then you wait for it to happen, then the response will come back. But the thing is with event is that you can kind of send messages out, it doesn't matter, nobody is subscribing, it doesn't matter, or nobody is listening, it's okay too. It's an event. And then there's a subscriber, if you're interested, you subscribe to it, the messages will be delivered to you, or you can do queuing, right? So queuing is slightly different, it's kind of one-to-one, kind of point-to-point type of thing. So anyway, so that's event. And now then let's take a look into event streaming processing. So basically, event streaming is the practice of taking action on a series of data points that originate from a system that continuously creates data. So that's talking about the events, is basically each of the data points. And the stream is an ongoing delivery of these events. So as you can see, if we kind of start programming event programming is maybe simple enough that you can do a publish and subscribe, one event go through. But in reality, too, we know that there can be like, a million or more of events happening, many data happening. There's streams of data that's happening. So we're kind of talking about large scale and ongoing delivery of these events. And also, too, with events, very often we have to also deal with back pressure because you can have tons of requests coming in, and then there's sometimes too you don't have anything happening too. So essentially it presents itself a new set of challenges when you're doing events and streaming type of work. And so basically a series of events can then be referred to as streaming data or data streams. So that's what we're going to talk about today is Apache Pulsar that can support you to doing that. And then there's also this terminology of complex event processing. So complex event as such, the word complex, meaning it implies a set of techniques as for capturing and analyzing streams of data as they arrive to identify opportunities or threats in real time. So for example, like fraud detection system, I believe that if you're already working with it, you probably will choose some form of event-driven event processor to help you with like managing, because you can have many connections that are happening, you need to be monitoring it. If something goes wrong, you sense that some suspicious activity is happening, you want to kind of send some sort of notification of notifying the threats too. So that's kind of a way of doing complex event processing. So as such too, is basically taking events and all the streams, you need to do more work with analyzing, capturing, how to capture all of these changes in all the data, and report on it, and doing also not just threat monitoring. It can be doing recommendation. If somebody is coming in to do shopping, you can do immediate, like if you're doing like artificial intelligence type of algorithms, you can analyze some sort of shopping pattern or viewing patterns, then you can present like recommendations on like say a shopping cart type of systems too. So that's kind of like complex event processing. So now then, let's get into like messaging. So event-driven versus message-driven messaging. This, actually, the definition is what I took from the Lightband, their reactive manifesto and all of the description. I find it to be very good. And event-driven, essentially, is dealing with one-to-many. Kind of sender can be emitting messages, and then interested subscribers can subscribe to the messages. You don't have to subscribe to it if you are not interested. So kind of a one-to-many type of scenario. Whereas for like message-driven, then it's basically the sender and receiver, you have to be known to each other. So the address has to be known. So you can have also like a continuous connection between the sender and receiver too. That's kind of like where we're talking about message-driven. So if you kind of look back at event-driven, that means the publisher doesn't have any knowledge of where the messages is going to. There's no need for you to know the address. But it's the subscriber who is interested, and very often we leverage on a broker. Kind of think of it, I like to use the example actually, when I have friends that ask me, what are you working on? And I can't just say Pulsar because it doesn't make sense. So I'd say, it's kind of like post office, right? If you need to mail some letters, well, slightly different, because you do need to address all of the messages. But let's think of it that way. You go to a post office, you have some messages you need to send out, then there's some way too, you need to identify these messages. So in computing terms, we're talking about using a topic, or as such, it's also a channel, right? Some kind of labeling of these messages. So you have some channel, you go to the post office, and then you say, okay, I have these messages, it's on this channel. And then it's up to the receiver, if they are interested, they have to subscribe to it, and then the broker, which is, in this case, like if you use the post office analogy, is the postmaster will have to kind of look at it and say, okay, subscriber is subscribing to channel ABC, so whenever there's message on ABC, you deliver it to the receiver side. So that's kind of differences between event-driven and message-driven. Okay, let me kind of make sure time is good. Okay, and now let me kind of explain then. Well, then now we're talking about events and the event approach, and then what would be before events? Actually, events isn't all new if you think about it, right? Because we have the phone, the telephone. Telephone already, too, back in the 70s or so, well, even earlier than that, it's already an asynchronous form of communication. And I like to also bring up to like Lightband, they have ACA, actor system. And the actor model, too, is actually, it's the Erlang that started with the actor model. So that's already kind of doing communication in an asynchronous fashion. Although at that point, too, it's not as sophisticated as it is now. So anyway, so I just want to bring up events already there. But the thing is, too, is that in a lot of, especially like IT corporation, right, we're still doing a lot of work in batch, too. So if you're not doing things in events, you probably are most likely doing all of your processing in a batch processing way. So that's kind of like the opposite. They juxtapose kind of each other. But batch processing as such, we know that something happens in a day and you collect all of the data. And then basically, too, because you don't want to kind of take up unnecessary network bandwidth during the day when you are servicing other more interactive type of applications, then you kind of save all of the processing at the off hours, and then you process all of the data changes all at once, kind of like that. So that's kind of batch processing. Everything is kind of happening after the fact, whereas events is, as data happens, you want to process it and give the result more dynamic as such. So, all right, let me kind of go to the next one. Okay, now then, let me then get into event messaging, the semantics and patterns. So what are there? Actually, I already brought it up too. So there's streaming, and then we're talking about Pulsar, right? So it says kind of publish, subscribe is a way of enabling to do streaming too. So basically, publishing client will send the data, and then again, broker is the middle person, the agent, and then the subscriber client will receive the data when the subscriber client is interested in the data, like that. So, well, since I already described, so I won't get into all the details. And now then, there's also message queuing. So message queuing, too, is basically a form of asynchronous service-to-service communication used in serverless and microservices architecture. Again, the queuing is more about point-to-point kind of processing, too. So the messages are stored on the queue until they are processed and deleted. So that's the thing too, is the one message goes to like one receiver only. So that's how the queuing is different from PubSub. Whereas like PubSub is you kind of mass, think of it like producer messages, it gets mass delivery, or can be, right, if you have multiple subscribers. But message queuing is one-to-one kind of delivery. So, and then it's by a single consumer, and it can be used to decouple like heavyweight processing to buffer or batch work and to smooth like spiky workloads. So that's kind of like the semantics you use. Okay, so a bit more about event streaming. And what is driving the change, right? So basically, too, there's a need to use, to leverage on real-time data that can enhance customer experience and also to create a competitive advantage for your business, too. So that's kind of like the primary goal. Like business these days are going after it. But I believe that the business are still trying to have to understand deeper of the value of doing event processing. But the thing is, too, is that what it promises for real-time delivery is very important. For example, like the fraud detection. You don't want to wait. You know, if something is happening, you don't want to batch process until the nighttime, then you realize somebody is trying to take money out of an account, and 10 hours ago, like that, you wanted to know it right away. So that's what is kind of useful to use event streaming. And then there's also like data pipelines that you will need to build up to do like artificial intelligence and machine learning type of kind of processing. But my understanding too, and talking with some ML expert, they said they are still doing pretty much like batch processing because they are processing like petabytes of data, so that they can't just do everything like in real time. But I believe that right now, with all the technologies that's happening, you can actually build out like real time data pipelines and process data in the petabytes, kind of in that range, so to speak. So. But yeah, so essentially, event streaming and all of these approaches kind of definitely, I think, the way to go to build out data pipelines that can enable high volumes of data to go through, as well as it manages the back pressure, right? You don't want to have too many requests happening and then it choke up your whole processor, too. So there should also be back pressure built into your system to kind of handle throttling of all of these requests, too, for example. So, okay, so then, the next thing, too, is basically using a PubSub streaming kind of approach. It helps you to meet the demands of large volumes of data generated by application operating at the edge, right, for example. So like the very typical example will be an Internet of Things, IoT type of applications. You can be collecting data continuously, right, and things like that. And then basically, you use this event-driven type of approach that can actually, manages and scale out very easily, because then it has the back pressure built in, so it won't choke that whole system from being like all like crash, essentially. So okay, let me go to the next slide. Okay, so again, then why event streaming? Because you want to watch for the events with the system or the application, and you want to then subscribe to the topics to see certain event types. So then you only subscribe to the ones that you are interested in. You are not forced to get event data from the events that you are not interested in. You want to make decisions on data in real time, not after the event. And you want to be able to ingest high frequency of messages with very low latency. So that's why it's event streaming. And now I will introduce then Apache Pulsar. So what is Apache Pulsar? So as such, it's an Apache ASF Foundation project. It was created by Yahoo back in 2016, or actually 2000, maybe 14, 15, about that time frame, because I believe they were using Kafka at first and realized that there are some shortcomings on Kafka. I mean, as such, Kafka is very useful, don't get me wrong, but I think it was designed at the time when cloud native wasn't as the thing back then. And then Yahoo realized that they have all the Yahoo Finance, Yahoo, all of their services data. Then they realized that they need something that can handle the cloud native kind of way of processing, especially they already launched things in the cloud in the early days. So then they decided to kind of start developing another tool, event streaming platform is essentially Pulsar. That's what it was born. And then they donated it in 2016 to Apache Software Foundation, and it quickly became a top-level project in 2018. Because, well, I'll get more into details too, but let me also kind of go through the list in here. So basically, Pulsar too has a very native, kind of cloud-native design already. It's cluster-based, and it supports like multi-tenancy. And then you can also have, you can basically have different kind of types of client to connect to it. There are already APIs, such as in Java, and then it's written in Java. So Java is kind of more like the primary, I guess, the supported client API to it too. And then there's also C# too, and Python and Go and Ruby, and also other kind of community contributed. Being Apache, there are also a lot of community contribution to the client set of APIs. So there's actually also Scala, but that's community contribution, for example, too. So now the one big thing about Pulsar is that it separates out the compute and the storage. Very often, if we look into this kind of event streaming type of platform, a lot of times it pops up where essentially if you look at it, it's essentially a distributed logging system. So it has to store a lot of messages and such. So Pulsar is already being designed from the ground up to kind of have a separate way of handling all of the complex, like log messages and all of these. And it relies on this library, another Apache project called Bookkeeper. So basically, then it separates out, it's basically delegate to another library framework to kind of help out with all of the log messages. So that's why, too, then Pulsar can focusing actually on all of the messages and processing them, too. So that's kind of like a big strength of it. Because think of the fact that in a cloud-native scenario, if you need to scale your system, you need to add more brokers, your topics and everything, you will need to kind of do it yourself, right? If you don't have something like Pulsar. But the Pulsar already has this built into it. So then it relieves you as a developer. You don't have to worry so much about how do I rebalance all of these topics? How do I do it? Don't worry. Pulsar already has it there. You just need to primarily doing configuration, and it will take care of things for you from that perspective. And then as such too, Pulsar being a message broker, message delivery, it's guaranteed. It supports all of the QoS, like quality of service, right? The QoS 0, 1, and 2, fire and forget, or deliver only once, or deliver at least once, and you can allow for duplicates. So all of these quality of service level, it supports as well. So all of your messages, you don't have to worry about it. It's guaranteed delivery. If the network goes away, if your broker is dead and everything, there will be mechanism already in your framework that takes care of making sure the messages that you want to deliver will be delivered accordingly because of the way how broker is designed in Pulsar. Okay, and then essentially too, with Pulsar too, now sometimes you deliver messages, you don't just want messages to pass through. Yes, at certain times you have it pass through, but there are times too in which you do need to do some message transformation in some small ways, for example. So in Pulsar too, there's this thing called Pulsar function. So essentially serverless kind of way of doing things. You can actually build out your serverless functions to handle certain types of messages, transformation during this whole pipeline processes as well. So there's this thing, Pulsar function. And actually over here, I didn't have this too, is basically there's also Pulsar IO, Pulsar connector, essentially. So you can actually, because being a streaming type of platform, you can actually build your system in essentially make your systems function as a set of pipelines. So with this kind of pipelining kind of way of doing things, you can actually connect different types of clients, different types of connector, right? You can have source and then sync and everything. You can have actually different things that you can all link them up together. And then there's also Pulsar, the connector, the connection too, that allows you to build your own if it isn't already supported, for example. Say, for example, in Spring 2, I think currently there isn't any, I was looking, there isn't any Spring formal connector for Pulsar, but I think there have been talks about it too, I believe. So, and I think maybe Tim, you'll be talking about it too, so yeah. Okay. And then there's also another thing is with Pulsar is that there's the tiered storage offloads too. So basically, it offloads data from hot and warm storage to cold and long-term storage when the data is aging out. So that's kind of nice too if you think about it as a developer. You don't have to worry about some of these kind of, otherwise would be more operational kind of things that are kind of mundane that you need to do it. But Pulsar already has this kind of built-in capability that helps you to move data. If it's aging out, you don't need it, it will automatically, some configuration you need to do that will move them off to long-term storage, to cold storage too. So, okay, so a bit more then about what is Pulsar. So it's this, you have to describe it. It's basically a unified distributed messaging and streaming platform is open source, right, originally developed at Yahoo, and contributed to Apache Software Foundation in 2016 and has then become a top-level project in 2018. It's cloud native in nature. You can actually do multi-cloud and hybrid cloud to it, and it's also works very well with Kubernetes as well. So, and there are also 4 reasons why Apache Pulsar is essential to the modern DataStax, which I'll kind of show you in a few minutes. So, but otherwise too, if you look into the right-hand side, some just data to kind of share with you too. The number of GitHub stars have continued to grow, right, since it became an open source ASF project. So I haven't had the latest data in 2022, but I think as you can see, it is continuing to grow. And the number of contributors too also have continued to grow. And also, if you can see, in 2021, about a year ago, you see that the number of contributors actually for Pulsar has surpassed that of Kafka by a little bit at that point. So it's clearly there's been interest too in Pulsar is what it is. And who else is using Pulsar, right? So all of these companies in here, as you can see, these are like big companies too that are already using Pulsar because they recognize its strength in doing like event streaming and in the modern cloud native way. So Pulsar is different. Just wanted to kind of point out again, I think it might be a bit of a repeat in here. So there's the producer, right? Client application send messages to topic managed by the broker. And then there's also consumers. Basically, they read messages from a topic managed by the broker. And the broker itself, too, is a stateless process that handles incoming message, and then the message dispatching, communicates with the Pulsar configuration store, and then stores messages in the bookkeeper instances. So now then, let me kind of bring in a little bit about the bookkeeper. So bookkeeper, Apache bookkeeper, essentially, as such the name implies, does bookkeeping, right? And it's a bit kind of more accounting. Think of it kind of all of these things with the log messages, it manages all of it. So if you look into the diagram over here too, then basically you can have multiple brokers that are serving, but the broker will interact with all of the bookies. And the bookies itself, because it's managing so many log messages that kind of flows through the system at any point in time, then basically bookie itself too, you can have multiple instances of it. And within it, they're segmented into different segments too for storage. And then if you need to look up too, it's basically very efficient as well. So, and then there's also then Zookeeper is there in the picture because Zookeeper will help to manage like the cluster, the metadata, it handles the coordination tasks between all of the Pulsar clusters as well. So that's kind of in a high level, all of these components of Pulsar. Okay, and then a bit about design principle, and it's basically a tiered architecture design. It's distributed architecture that supports like horizontal scaling. And then all of the partition topic abstraction will basically, because it's partitioned, it's basically, you don't have to worry so much too about all the complexity as consumer of these messages, for example. So again, I kind of bring up to basically in any kind of distributed messaging kind of system, scaling is kind of a big issue, right? And you need to rebalance all of the partitions. If you have all of the topic partitions in different, instances of your broker and everything, once, you need to scale up or scale down, then you need to rebalance all of it too. How do you do it? And Pulsar already has this built into it too. And basically, so another challenge is basically tightly coupled persistence and message serving capabilities. So in this case, Pulsar you don't have that problem because it's separate out, it essentially loosely coupled. You don't need to worry about persistence part, and you don't, is Pulsar managing all of the message serving capabilities. Okay, so that's pretty much that. And over here too, there's another slides too. This is actually from my group too, so I thought I'd show it too. But basically, so what is the big deal, right? You would say, okay, Pulsar is just another like event messaging kind of platform. Yeah, it's event streaming. But again, we talk about this is fast, low impact, and then horizontal scaling that it supports. And the broker is stateless, right? Built-in load balancing, instantaneous scaling. And if you need to, any recovery too, it's basically zero impact as well. And then Bookie, I wanted to highlight a little bit in here, is basically scalable and wall-based. It's a write archive, forgot exactly, layered or based, but it's a write protocol for doing bookkeeping type of work. So it's like specification-based too. Fault tolerance too, it's low latency as well. And then you can tune it too, a bookie too. There's a tunable consistency for message replication. So if you kind of think of those things that you don't want to do, right? All of these bookie will take care of that for you. Ensemble size, the right quorum and act quorum, all of these, they're specific to doing kind of accounting, log messaging type of things. Bookie will handle that for you. And it's very fast. The write is very fast too, and through their journaling system. And then also data persistence too is through their segment-centric, through their electric or kind of ledgers too. So this is kind of like the bookie side, the bookkeeper side. So you can kind of rest assured that, okay, there's bookkeeper handling all of these logged messaging, then just rely on Pulsar helping you to deliver, managing all of your messages too. Okay, so over here too, again, a quick kind of summary is that it's basically Pulsar is the next generation of enterprise messaging because it's unified. It's a kind of think of a unified solution for PubSub. You can also do queuing. Now you're wondering, how do you do queuing? So in PubSub too, as you know, right, you do delivery of messages, but there are 4 modes of doing PubSub in this case. You can do like exclusive mode, which means that's actually essentially doing queuing. So you can have essentially a topic, and basically for that subscription, you only identify only one consumer. Actually, my next slide will kind of explain that for you too. So I'll kind of get through this first. And then there's also like queuing, and there's also streaming, right, that handles, and also the message mediation and enrichment part. And out of the box capabilities will, support like cloud, like on-prem and hybrid cloud, and geo-replication. Also, then multi-region support as well. So that's also another, the 2 things that are very powerful in Pulsar is the geo-replication. Essentially, too, that means like it handles your data in like different regions too. So then like on the developer side, you don't actually need to worry writing as much code because as such, the framework itself already can handle it for you. So all you need to do is kind of configure it properly. Now, geo-replication is also kind of probably important too, especially when you're dealing with data in different parts of the world. For example, like in Europe, there you have GDPR type of data privacy type of thing. You need to do certain type of replication. You need to do certain things to your data. You can actually configure it rather than worrying about how to deal with each region accordingly, like that. And then there are also multi-region support, which I'll get into a little bit, and then also data lake integration. For example, now we are also working with integrating with Apache Pinot. You may have heard of the real-time analytics data lake type of systems. So we also can kind of integrate with that too. Okay, so how is it different? I think I already kind of talked, so I won't get into too much of it, right? And then these are like just showing you that it has a very rich ecosystem of connectors and clients. You can actually have everything there, and you can essentially leverage on Pulsar and to do all of the connection on the whole ecosystem for you. Okay, so just to kind of reiterate again, right, some key differentiator, right? Number 1 is basically separation between the compute and storage. So it's basically, again, over here, as you can see, it worries about all of just the broker side of things. And then it delegates all of the bookkeeping side of log messages, the distributed logging, the storage, to bookkeeper, right? And then we have a stateless broker that handles producers and consumers. And storage is handled by Apache bookkeeper, and it's basically fast and low impact horizontal scaling capability. And number 2, I just mentioned too about geo-replication over here. So basically, you hands-off real-time message replication across data centers too. And over here, to flexible message replication mode and patterns, you can have synchronous versus asynchronous, active, passive, or selective message replication. And basically, you can have capabilities to meet different data compliance requirements across geo-regions, especially if you work for big companies that are multinational. This would be a really good feature to have. And then there's also multi-tenancy too. So essentially too, it consolidates all of your messaging and streaming platform, makes the operation kind of simpler in this case. And you can have different permission control within the business domain context. You can set up like security, compliance, and auditing, all of these. But as you can see in the diagram in here, you can have a Pulsar cluster. Underneath too is the way you divide things up is by tenants. So you can have a tenant. For example, your finance department is a tenant, and then underneath there are different namespace to serve different purposes. You can have different message topics underneath, and you can kind of divide it in that case. And this example here also showing you can have another tenant, for example, marketing too, that have, doing all of the messaging that's only pertains to marketing department. And then another one is doing product engineering, for example. And then another differentiator is basically the flexible message processing model. And so this is the one I was going to say is about the using queuing, right? So basically, for the topic, you can have out of the box like multi-subscription modes. There can be 4 of them. Exclusive, and over here, if you look, oops, I'm sorry. So exclusive, the top one is basically you can have a subscription that's only dedicated to one consumer. So that becomes kind of a one-to-one, point-to-point type of messaging. That's a form of queuing, too, that you can do in Pulsar. And then you can also have a failover mode in which you can have 2 consumers, but one will act as the failover if there, for some reason, the first one goes away. And then there's also this shared subscription, too. So shared subscription is kind of very useful in a cloud-native clustering kind of environment that you can share among different consumers that are, kind of all kind of clustered, right? Kind of what you call like duplicated or replicated too. And then the thing is, if you want order, then you can actually use a key shared type of topic kind of subscription mode to it. Then it will keep the order of when it's sent and when it gets delivered too. So, okay, so that's that. And then, so now, question is about like why Pulsar, right? Sorry, I kind of went through all of these again, but there's this one article too, actually from Confluent too. It's Kafka versus Pulsar that if you're interested, you can kind of take a look into this one, the top one. And there's also another article written too about Apache Kafka versus Apache Pulsar event streaming comparison too. So you can read up on those. And basically, too, why you should consider Pulsar is if you need both queues like RabbitMQ and then stream processing like Kafka, maybe you want to consider Pulsar because it can do both PubSub and also like queuing too, as I kind of already show you. And if you need geo-replication, right, and you want to choose Pulsar, and multi-tenancy too, for example. And then you want to persist your messages for a long time and you don't want to offload them to another storage, maybe you want to consider Pulsar. And performance is, if it's critical for you and your benchmarks have shown that Pulsar provides lower latency and higher throughput. And then also, too, a nice thing about Pulsar is if you're running things on-prem, you don't actually need to change that yet because you can kind of bolt on Pulsar, too, and kind of run on top, and you can kind of extend all what you already have without having to change things underneath, too. Okay, so a bit of a DataStax. I work for DataStax. So DataStax flavors of Pulsar. So basically, we have what we call like Astra Streaming, and this one is a Cassandra-based kind of streaming, Cassandra on the cloud, but we have added in like Astra Streaming too. So this essentially is a managed Pulsar, but the thing is I'll give you a code too. You can all get like $25 like US dollar for credit to start up with per month, and it's actually quite sufficient if you want to do like, kind of some single-use type of, kind of for your personal research is actually quite sufficient. And then if you want to use like just as is, right, open source, well, on the right side, you can do a pure open source Pulsar, and that's all community driven. Or if you want to, you can actually use the open source, and that's called Luna Streaming, and that you can also pay for enterprise support too, in this case. So. And basically, DataStax, we have streaming offers, and right now, again, we have left side is the Luna Streaming. You host it yourself. It's open source distribution, and then it's free to use, and it's available now. But Astra Streaming, too, we're going to be announcing it pretty soon, but right now we're still seeking some early access participants if you're interested, too. It's fully hosted, too. It's open source, and it's fully supported offering, too, and it has serverless consumption pricing, too. So. Okay, so, and how is Pulsar is different from other different event streaming platforms? So things just to be aware of with Kafka is that, if you want to scale Kafka, it can be tricky because the way Kafka is designed, it doesn't separate out the compute and the storage side. So if you need to scale out, and if you're already working with Kafka, you realize that, well, then you have to kind of calculate again, how many partitions, how many topics, all of these things, if you need to scale, is a lot of work for you to do too. So that's where Pulsar kind of comes in. It's already kind of built in, so you can rely on Pulsar, the framework, to do that for you. So that's that. And Kafka also doesn't have native multi-tenancy, right, with complete isolation of tenants too. So it's different. And storage can become quite expensive too in Kafka. If you need to store data for a long time and all of these cost implications. So you have to do a lot of things, I guess, by hand if you're using something like Kafka, another messaging platform. And then all of these things is already talked about. And basically, if you need to rebalance your cluster, basically it's kind of impact all of the performance of all of the connected producers and consumers too. But whereas Pulsar already has this built in, so I want to emphasize that that's actually a very powerful feature that Pulsar has. So. Okay, so this is just a diagram to kind of describe too. If you look over, actually on the right side, segment-oriented log message management too. If you look into Apache Kafka over here, it manages, right, all of the partitions of Kafka, and then you have to manage all of your broker. And it's, as you can see from a kind of architectural point of view, whereas if you look into Apache, Pulsar, and Bookkeeper, all of these two, it's already kind of easier in terms of scaling up and down all of the segments in all of your log messages. All of these are handled already by the framework itself, so then you don't have to worry about it as much. Okay, let me see the time now. Okay, so now just a very quick demo. It's not actually a demo, but just wanted to show you. But okay, so you can visit the Pulsar website to get more information, but as such too, if you go over to DataStax, as I mentioned, so astra.datastax.com, I'll have it on the slide too. So you can actually, you're welcome to sign up at any time too. So I've already signed up, so you can see that, right? Okay. Okay, this might be a bit of time. Okay, good. So over here is essentially Cassandra. So you can actually, as I mentioned, right now, right, I got $21, but basically you get $25 US dollar to start with. And if you run into problems with the region, let me know, because I can get also special code for you to unlock too. So, okay. And then, so over here you can create your database, play around with Cassandra. And then there's also create streaming, is where you can actually quickly kind of create, right? You can create your tenant name, let's say, Spring.io or something, and then you can actually select a provider and region. You don't actually pay for it, right? Let's say I want Google Cloud, I select US Central, that's where I am, and then you just create a tenant. This is gonna take some time too, even though it comes up. And so over here too, then as you can see, it's actually, over here you can get started with it quite quickly. Over here, it guides you to create a topic. And how do you connect? If you go over to connect, it gives you all of the information about your tenant, your plan is a free plan. This is GCP, US Central for the region, and the broker, if you want to use SSL2, is that one. And then if you don't want to, it's just actually, if you just want to connect it, for example, if you don't want to use this Astra Streaming, you can also have, we also have it on Docker as well. Then you can run it locally in your Docker desktop, for example. Or if you want to, you can download the tarball and then just install your binary and run it local as well. So, but this is just another way. I just thought it's quickly, I can kind of show it to you. So all of these things, and then the token manager, everything's already there. You kind of basically all set to go. And then if you need to create a topic, you go over here, topic, you can just add a topic. Let's say spring topic. Like that. You can do persistent or non-persistent, and partition and not partition too. So it's actually pretty quick. And then you click on it, spring topic is created, is persistent in this case. And then all of the namespaces, all of these things in here. And then again, I mentioned about Pulsar functions. So if you need to do any kind of message transformation, you can actually write your functions in here too. And today I don't have time to kind of get through all of it, but otherwise too, it also guides you through this. There's a bit of a caveat, but contact me, and then actually on my Twitch stream, I've been kind of showing some of these things, so I won't be showing all of these examples today. And then you can also like have syncs too, then you can quickly also create a sync that, for example, you can write to another Astra DB or writing to Elasticsearch sync. That's also like in there too. So over here, you can have Astra DB, Elasticsearch, or JDBC, all of these different destinations, Kafka as well. So all of these, and again, if you need information over here, if you go back to connect, it shows you all of these. And if you want to connect a Java client, we have coding example to guide you how you can start with writing, using Maven or using Gradle. The producer code, a simple, basic Pulsar client, how do you write it? It's already there. How do you consume it? It's also in there as well. So this is just kind of a super quick kind of demo to show it to you. And again, how you sign up, I have that on my slides to the URL. So I'll go back. Oh, I'm over here. OK. OK, so with this, I think I'm kind of timed now for the next presenter. So how do you go from here? And please keep in touch. So these are all the links to all of the Pulsar, Bookkeeper, Zookeeper links on apache.org. And then if you want to look up in DataStax, we have our astra.datastax.com, the managed cloud that I just showed you. You're all welcome to sign up to using your email address. No credit card allowed, or no credit card required, I should say. OK, and then there's also a link to Astra Streaming, Luna Streaming, and there's also a feature called Change Data Capture, CDC, for Astra DB2 that you can look up to. And then this is actually the information for if you want to sign up for Astra DB for some extra $200 US dollar in credit, you can give the code open source 200. Again, I have these slides available for you with this conference. And then this is my Twitch stream. So usually every Wednesday afternoon, US Central Time, I'll do a Twitch stream. So that's where I kind of explore further into writing some code and then deploying them and showing all kinds of stuff on there. So, and then there's also a meetup group that my team has started. Our community manager has started the Apache Pulsar neighborhood. And there's also another, like a wiki kind of site, Apache Pulsar neighborhood as well. So you're welcome to join and contribute and kind of ask questions at any time. We're still kind of working out a lot of plans and to bring the community together or kind of start to build a community as well. So, and then with that, I want to thank you for having sat through my talk. I hope it has been useful. And please stay in touch and follow me on LinkedIn or Twitter, or also my Discord too. I have a Discord server. If you want to continue the conversation, I would like to invite you to do so. So thank you very much, and please let me know. Thank you.